When it comes to graphing a piecewise function, the best way that I have found to do this is by using a table of values. So here in my problem I have 3 different equations, so I have 3 different columns for each one of those equations. I also have restricted values for all of them, so that's where this table is going to come in. So if I start off with the very first equation, x plus 3. I know that this is only going to work for x values that are less than or equal to 0. So this number is always going to be either my starting or my ending point. So I'm going to go to 0 on my table, and I'm going to have different circles depending on the inequality sign. So just like we had dashed lines and solid lines when we were graphing inequalities on a coordinate grid, I'm going to either have open circles or closed circles for each inequality. And it's exactly the same way as they were for the lines. So an open circle would be for the less than or greater than. Closed circles are going to be for the greater than or equal to and less than or equal to. So here, since I have a less than or equal to sign, I'm going to have a closed circle. So at my ending point here, I'm going to actually draw in a closed circle so that I know that last point or that final point is going to end with a closed circle. From there, I'm going to have all of the negative values that go on forever. So I don't need positive 1, positive 2, 3, 4, or 5, because if I would put any of those into this statement, they're all going to give me a false statement. For example, if I would use 1, 1 is less than or equal to 0, I know to be false. But if I would use my negative 1 above that 0, negative 1 is less than or equal to 0. So everything above 0 is going to give me true, everything below would give me false. So I'm going to scratch out 1 to 5 since I can't use those values. So to fill in the rest of the table, I'm just going to plug those values of x in to the equation to get the y value. So if I start with negative 3, I'm going to take negative 3 plus 3, which would give me 0. Then negative 2 plus 3, which would give me 1. And negative 1 plus 3, which would give me 2. And 0 plus 3, which would give me 3. So I have 4 points for that first graph. Now if I go to the middle graph, the 2. This one is only existent between 0 and 2. So this is a nice statement. It gives me a starting point and an ending point. So if I go to the 0, the inequality that follows is the type of circle that I need to be using. Since it is less than, I'm going to be using an open dot. So in my 0, I'm going to be putting an open dot. And then I'm going to stop at 2, and the circle there is going to determine by the less than or equal to sign. So I'm going to be using a closed dot. So I'm only going to have 3 points, 0, 1, and 2. Everything else I can scratch out. They're not necessary for this second portion of my graph. So like I did in the first equation, I can plug in my x values to get to my y. The only thing with this equation though is I only have the whole number 2 and no variable. So all that means is that each one of the y values is 2. It's just going to be a horizontal line. My last equation says that x is greater than 2. So 2 is going to be my starting number, and then its inequality sign is greater than. So since it has no line underneath, it's going to be an open circle. So I'm going to put an open circle at 2. Okay, now I need to determine where I have my true values and where I have my false values. Since x has to be greater than 2, if I go to 3, that would give me a true statement. 3 is greater than 2. So everything from 3 down will give me a true statement, and everything from 1 up would give me false. So I'm going to scratch out the top portion of that table. Now like I did in the very first column, I'm going to plug in to the equation since I have an x variable. So my first x here is 2. So I have 2x subtract 1. So I'm going to take 2 times 2, which is 4, subtract 1, which would give me 3. Then I have the x value of 3. 2 times 3 is 6. Subtract 1 would give me 5. Then I have x to be 4. So 2 times 4 would give me 8, subtract 1 would give me 7. And then 2 times 5 would give me 10, subtract 1 would give me 9. So those values you do not have to get mentally. You can use a calculator and you can plug them in to get the y values. Now it comes to graphing. So I'm going to start off with my first equation. I'm going to plot my 3 points. Since the final point of 0, 3 is going to have a closed circle, all 4 of those points I'm going to plot will all have closed circles. So I have negative 3, 0, negative 2, 1, negative 1, 2, and 0, 3. Okay, now I need to figure out where my values are going to continue off to. So is my line going to be going downwards into the negative numbers, or is it going to continue upwards to where the x's end up growing positively? Since I scratched out my x to be 1, 2, 3, 4, and 5, I don't want my graph to be pointing off to the right. So I'm going to start at that 0, 3, and it's going to continue downward. So then I go to the middle graph. I have 3 points. So at 0, 2, I have an open circle, and at 2, 2, I have a closed circle. Anything in between will also have a closed circle, so 1, 2 will be closed as well. So if I put a dot at 0, 2, I'm going to plot that with an open circle, and then 1, 2, and 2, 2 will be closed. And I'll connect those with a straight line since I know it's only between those 3 values. Then my last equation, I start off with an open circle, but everything that will follow will be closed since those are all included in my inequality. So if I go to 2, positive 3, I'm going to have an open dot. And then at 3, positive 5, I'm going to have a closed. And then at 4, positive 7, I'm going to have a closed. And at 5, positive 9, I'm going to have a closed circle. Now it's going to come down to where is this graph going off to. Since I know that 2, 3 is my beginning point, the rest of my graph is going to go upward. That's where all of the x's are going to continue to grow. So here is my graph for my piecewise function.